Today we're going to cover section 5.2 of your BJU Press Geometry textbook. So this lesson is all about statements and quantifiers when it comes to logic and proofs. So we'll learn what a statement is in terms of logic in geometry, and then we're also going to learn what quantifiers are and how to apply them to our statements. And then we're also going to learn what a negation is, and we're going to learn how to form negations of statements. And then we're also going to learn the symbols for all of those. So a statement is going to be a sentence. So this sentence has to be a true sentence or a false sentence, but it can't be it can't be a sentence that it might be true and it might be false. It just depends. That's not a statement. A statement is either going to be true or false, very set in stone, it's going to be this or this. So let's do some practice on determining if a statement is a statement, and if it is a statement, if it's a true statement or is it a false statement. So for example, if we have x plus 7 equals 4, is that a statement? If it is a statement, is it a true statement or is it a false statement? So because we don't know if x plus 7 equals 4, we don't know if that's true or false because we don't know what x is. So because of that, we would say that's not a statement because we don't know if it's true or false. It could be true, it could be false, but since we don't know, we're going to say it's not a statement. Let's try this one. 3 plus 5 equals 6. So we know that 3 plus 5 is 8 and it's not equal to 6. However, we know that it is a false statement. So it is a statement, it's just false. So the correct answer would be that it is a false statement. Next one. This sentence is false. So this is a little tricky because you're like, well, if you're saying the sentence is false, then that means is it a true statement? Is it a false statement? So it is a little confusing. So we would say not a statement because it's unclear whether our statement is true or false. Next one. 3x minus 9 equals 3 times x minus 3. So this one, you're like, oh, well, there's another x. That means it's not a statement. Not necessarily true. If I were to simplify the right-hand side, I would distribute. So 3 times x is 3x. That's what we have over here. 3 times negative 3 is negative 9, and that's what we have over there as well. So we had 3x minus 9 equals 3x minus 9. So it doesn't matter what we have for x, this is still going to be a true statement. Alright, so now that we know what a statement is and what a statement isn't, let's go ahead and talk about the symbols for statements. So because we're having to write sentences, that can take up a lot of space and take up a lot of time. So what we usually do is when we're dealing with mathematical logic and we have statements that we're working with, we're going to use symbols to represent those statements. We usually use the letters P and Q to symbolize statements. So for example, we'll let the letter P represent the statement, dogs have fleas. And then we're going to let the letter Q symbolize the statement, baseball is fun. So again, we're using letters to symbolize statements. Now let's talk about a negation. So negation kind of sounds like negative, right? Well, which is kind of like, you can think of it like it's opposite, right? So a negation of the statement is going to be the opposite of whatever is being said because you're negating it. Whatever it is, you're going to say it's not, right? So if we say geometry is fun, then if you want to take the negation of that statement, you would say the opposite, which is geometry is not fun. So in symbols, instead of having to write all of that down, right, if we say the first statement is represented by the letter P and we want to negate it, we would just use this little squiggly line right here in front of the P, and then that means that that's going to say not P. So this symbol represents not P, or the negation of P. So if P is geometry is fun, then not P is geometry is not fun. Okay, so next, let's talk about quantifiers. So in logical reasoning, anytime you use the word all or use the word every in a statement, all and every are going to be a quantifier. We're talking about a quantity of people, right? And if we're using all and every, we're talking about the whole universe, right? So we call that a universal quantifier when you're talking about the word all. So all is the universal quantifier. Because it's quantifying, we're talking about numbers, and it's universal because we have everybody's included, all. So in symbols, remember, we don't like to write all these sentences. So instead of writing all of P, we'll say this little symbol here. It's like a little upside down A, kind of like for all. And that little upside down A is a symbol for the universal quantifier, which means we're talking about everything in the universe, right? If we want to negate a universal quantifier, you have to make sure that our statement is not true for everybody, right? So if we say all flowers are pretty, that's going to be AP, right? All where P is the statement. So that means we have all P's. So P would be flowers are pretty. And if we put the little upside down A, then we're saying all flowers are pretty. And if we want to negate that, so that means that we're going to use this little symbol, the not symbol. So not all flowers are pretty. And so if we're going to say not all flowers are pretty, in order to say that, we have to not only, we have to change the verb. So if the verb is are, then we change the verb to are not. But we also have to change all, right? If we have all, then that means that the opposite of all is just one, right? So we're going to say there exist, or there's one. So there exist flowers that are not pretty. So it's almost like you're switching. So not only are you switching the verb, but then you're also switching the quantifier. If the quantifier is all, then you're just going to say there exist, right? There's one. Okay, and instead of saying there exist flowers that are not pretty, you can just say not all flowers are pretty. You could also say some flowers are not pretty. So again, this is an example where we switch the verb. So are became are not, the negation. But if you do that, if you negate the verb, then you also have to negate the quantifier. So all has to be changed to some. So you know how I kept switching the quantifier from all, and we changed it to some, and we changed it to there exist? That quantifier that we changed from the universal quantifier is called an existential quantifier. So that's the opposite of the universal quantifier. So the universal quantifier is all or every. The existential quantifier, which is a backwards E, implies one or more, right? It's just something that exists. There's one. There's at least one, right? There's one or more, or there's some. Maybe not all, because that would be the universal, but there's something that exists, at least one. And that's what we call the existential quantifier. So they're kind of like opposites. So if we want to negate an existential quantifier, the statement cannot be true for any. So just like how we had to change universal to existential whenever we negated it, we'll have to do the same thing if we want to go from existential to and negate that. So let's just start with the statement. We're going to let statement P be dogs have fleas. Okay? So if we want to say the existential P or EP, we would say there exist dogs that have fleas, right? So we just want to say that there's something that exists. Not all dogs, but there exist dogs that have fleas. Okay, and if we want to do not EP, then we're trying to say that we want to say that the opposite. So there exist dogs that not have fleas, but that doesn't make sense. So remember, whenever you negate it, not only do you have to switch the verb, but you have to switch the quantifier too. So we can say, instead of there exist, we're going to say no dogs have fleas. So again, we switched from existential to universal. So let's do some examples. Let's start with the statement, girls are logical, right? So if we want to do all AP, that would be all girls are logical. And if we want to do not AP, then we'd have to switch, not all girls are logical. And then if we want to do EP, or the existential, we would say some girls are logical, right? Or there exists a girl that is logical. And then if we want to do not EP, then we would say no girls are logical. Okay, let's do another example. Cars are expensive. So for AP would be all cars are expensive. Not AP is not all cars are expensive. And then EP is some cars are expensive. And then not EP would be no cars are expensive. All right, go ahead and try some problems on your own.